In class last week, we were talking about linear programming. I had mentioned in passing that we can also do this by hand, and in fact, before Excel was around, that's how it was done. I'm going to give you an example of doing this by hand, and you're going to see the advantage of having a tool like Excel, but I thought it would be useful just for you to see what the process was so you to understand where these numbers are coming from and how these numbers are generated. So we're going to look at the first class example from the Week 5 problem set. And let me just read this, but you can also open it up from Moodle. The Flair Furniture Company produces inexpensive tables and chairs. The production process for each is similar in that both require a certain number of hours of carpentry work and a certain number of labor hours in the painting and varnishing department. Each table takes 4 hours of carpentry and 2 hours in the painting and varnishing shop. Each chair requires 3 hours in carpentry and 1 hour in painting and varnishing. During the current production period, 240 hours of carpentry time are available and 100 hours in painting and varnishing time are available. Each table sold yields a profit of $70, and each chair produced is sold for a $50 profit. Flair Furniture's problem is to determine the best possible combination of tables and chairs to manufacture in order to reach the maximum profit. The firm would like this production mix situation formulated as an LP program. So as you can see right there in the problem, we are interested in figuring out a max for this linear programming. So I'm going to do, and this is the way I like to set up my problems when I have this, when I'm doing this, is to first set up in columns, excuse me, the two variables I'm interested in. So I'm interested in tables, and I'm interested in chairs. And so what do we know as far as how we figure out our profit? We know that each table is going to produce $70 in profit, and each chair is going to produce $50 in profit. So I would set up my profit. I'm going to let T equals table. So 70T times, plus 50C equals my profit. So what's next? I want to set up my constraints. Let me just get rid of this, figure out how to get rid of this extraneous stuff here. Excuse me while I do this. That's good enough. Alright, so what are my constraints? I know that my two of my constraints have to do with carpentry and painting and varnishing. So what do I know about carpentry? I know that each table takes 4 hours of carpentry and 1 hour in painting and varnishing. And each chair takes, takes 2 hours of painting for the tables. And each chair takes 3 hours in carpentry and 1 hour in painting and varnishing. So basically what I've tried to do, and this is a very big help for me even if I'm using Excel, is try to set this up as a table. So in my columns, I have my two variables, and in my rows, I have my constraints. Now, what else do I know about carpentry? I know that I have 240 hours of carpentry, and I know that I have 100 hours of painting and varnishing. So let's turn this into a formula now. 4T plus 3C has to be less than or equal to 240. For painting and varnishing, 2T plus 1C has to be less than or equal to 100. I also know that my tables did this in class, have to be greater than or equal to 0, because I can't have negative numbers. And for my chairs, have to be greater than or equal to 0, so I don't have negative chairs. Okay, so let's continue. When we're setting up a linear programming example, we're basically creating, when we're using two variables, in this case chairs and tables, we're creating an XY chart. So if we think of tables as our X and chairs as our Y, we're going to create a series of lines to graph the optimal chairs and tables so that we can figure out how many to make of each. So what we're going to do is first take this first problem, and remember this came from the previous screen, our first constraint. So we're going to graph this line here. The way we do that is we substitute 0.
What are you doing?
So we're going to substitute 0 for both t and c to figure out what each equals. So let's just walk through that. Now the first thing I want to do is, because I'm solving this now as what's called a linear equation, I'm going to modify this just for a bit to change this less than or greater than to just a plain old equal sign. And I'm doing that because I'm trying to figure out exactly the angle of this line here and the position of this line. So let's say first that we're going to substitute t with 0. If we substitute t with 0, that allows us to figure out what c equals. So we end up with 3c equals 240. And if we saw for c now, we divide each side by 3, c equals 80. So if I graph this now, x is equal to 0 because this is tables. So if 0, and then c equals 80. So 10, 20, 30, 40, 50, 60, 70, 80. And I end up with a line right there, or a spot right there. So that's when I saw for c by substituting 0 for t. So let's do the same thing for c. I'm going to substitute c with 0. Which gives me 4t equals 240. Solving for t, I end up with 60. So that means that when c equals 0, t, 20, 30, 40, 50, 60, t equals 60. And now what I do is I just draw a line between these two spots. What this means then is that my first constraint says that I can't have any values to the right of this line. Okay, so let's now solve the next constraint. This was the constraint for painting and varnishing. 2t plus 1c is less than or equal to 100. Again, because I want to graph this line, I'm going to change this to a 100. So first I'm going to substitute t with 0. Which gives me c equals 100. So t equals 0 and c equals 100. And then I replace c with 0. So 2t equals 100, which means t equals 50. So when I graph that, 10, 20, 30, 40, 50, I end up with, oh, I guess it's more like there. So if I graph this, then I end up with a line like that. So again, I know that I can't be outside of those bounds. I also know in this range. So the next step then is to figure out, plug our numbers into our formula, our profit formula, to figure out what the best option is. So if you recall, we have really four points that we know about. We have a point here, and this one is x equals 0, y equals 0. We have a point here, and we know this is, let me correct this, t equals 0 and c equals 0. So tables and chairs both equal 0. This point here, tables equals 0, or I'm sorry, tables equals 50, and chairs equals 0. We have this point right here where tables equals 0 and chairs equals 80. And then we have a point right here where these two lines intersect. So the next thing we need to do is figure out where it is that these 2 points intersect and what those values are. The way we do this is with additional algebra. So you'll see here I have my 2 constraints, this one for carpentry and this one for painting and varnishing. So I'm going to solve these and solve these together so that I can figure out that additional coordinate. So the first thing I need to do is find out how I can eliminate one of these variables. And the way that I do that is I'm going to take this formula here and multiply it times 2 so that t is the same on both of these equations. So again, if I multiply this times 2, I end up with 4t plus 2c equals 200. So I took this times 2 to get 4t. I took this times 2 to get 2c, and I took this times 2 in order to get 200. Now the next thing I'm going to do is I'm going to take this equation and I'm going to subtract this equation. Done with this for now. So I'll take 4t minus 4t, and I end up with 0t. 3c minus 2c equals 1c. And then 240 minus 200 gives me 40. C equals 40. Now what I do is I just take this 40 and I stick it into this formula here. And so I have 4t plus 2 times 40 equals 200. So 4t equals 80, or 4t plus 80 equals 200. 4t equals 120. So t equals 30. So now I know that this final coordinate, t equals 30. Let's try that again. 30. And c equals 40. And that's this point right here. So the last step now is to take these four values of tables and chairs and plug them into our original profit formula, which recall was 70t plus 50c, to see which one ends up with the highest profit. And you can see where this is going. So if I take 70 times 0 plus 50 times 0, I end up with a profit of 0. If I let t equals 50, 70 times 50 equals 3,500 plus 0. So in this case, I end up with a profit 3,500. In this instance, I let t equal 0 and c equals 80. So I end up with a profit of 4,000. And in this last instance, I let t equals 30, which gives me 2,100, plus c equals 40, which gives me 2,000. So that gives me a profit of 4,100. So the combination of tables and chairs that will realize the greatest profit for me is a combination of making 30 tables and 40 chairs. Now you know how Excel calculates this, and now you can know how great it is to have a tool like Excel so that you don't have to do all of this by hand. I will also say this way by hand only works with two variables, and it's very seldom that you only have two variables, and so you wouldn't want to do this by hand.